Dr. Vardiman received his B.S. in physics from the University of Missouri, a B.S. in meteorology from St. Louis, Missouri University in St. Louis, MS in atmospheric science at Colorado State University, and a Ph.D. in atmospheric science at Colorado State University. He was an officer of the United States Air Force in the Air Weather Service, Aerospace Modification Division, and taught at the U.S. Air Force Faculty Graduate Student Summer Research Program. He received a research grant under the U.S. Air Force Mini Grant Program to study the weakening of a millimeter wavelength satellite signal in rain or snow. Easy for you to say. He later worked as consulting meteorologist at Western Scientific Services in Colorado. He was consultant to the Colorado Governor Advisory Panel on Weather Modification and was a meteorologist for the Bureau of Reclamation in Denver. He has been a professor of the Natural Sciences Division at Christian Heritage College since 1982. He's a professor in the Department of Geophysics at ICR down in San Diego. He received the Air Force Commendation Medal for Meritorious Service, the U.S. Bureau of Reclamation Outstanding Performance Award, and the Christian Heritage College President's Award for Distinguished Service. He's a member of the American Meteorological Society. He's written many books, articles, and his two books that he's written are out in the front lobby there for you to look at. And he's going to be talking about the Ice Age tonight, and it's called The Big Freeze. So please welcome Dr. Larry Vardiman.
Well, I didn't expect him to read all that. When they ask you to send a resume, I assume they're just going to pick a few things off here and there. I spoke up at the Creation Science Association up in Fullerton about a year ago, I guess it was. And Dave Coppage is involved with that particular group. And following that meeting, we had him come as part of our trip to the Grand Canyon this last spring. He led one of our groups. If you recall, we had a lot of really bad weather late in the spring, and it washed out two of our trails where we take people backpacking. And we had to shift those two groups over to the Indian reservation, and none of us had ever been on that trip. So Dave Coppage graciously at the last minute came and helped guide our group down into the Indian reservation. And really, I was impressed with Dave. I don't know how many of you know him, but he is really an outstanding creationist, really enthusiastic. So if you've seen his video, you know how enthusiastic he can get. So really enjoyed getting to know him. When I was invited to come here to the South Bay Creation Association, I meant to ask some of the leadership, and I forgot to do that. Why is it called South Bay here? I thought this was west side of Los Angeles. What are you south of?
Down Santa Monica. South of Santa Monica.
South of Santa Monica.
South of Monica.
It says South Bay, though. What is the bay?
San LA Harbor.
Oh, I see. Okay.
Monica Bay.
I don't get to LA very often. Those of us who live in San Diego, we tend to stay there. So I don't know that much about LA, so I had to follow the map pretty closely, so that helps a little bit. Well, I want to talk to you a little bit tonight about the Big Freeze, a biblical ice age. And before I get into that, though, I want to give you a few references to some of the books that we have on the back table that are related to the presentation I'm going to be giving tonight. I didn't bring as wide a selection of materials from ICR because my back is giving me trouble. That's why I'm kind of leaning over here. But I thought I would bring a few that might be related closest to the topic. An Ice Age Caused by the Genesis Flood by Mike Ord. This is a monograph that we published based on some technical work that Dave had done, or I'm sorry, that Mike had done. Mike is a meteorologist with the National Weather Service in Montana. And this is kind of the studies that he's done for many years, and he's published many papers in the Creation Research Society Quarterly. And it was basically his basic idea that has developed for my research for the last 4 or 5 years, so I have to give him credit. This book is an excellent source of dealing with the Ice Age from a biblical perspective, and it's more than just technical material, more than equations. It deals also a lot with cultural issues, a lot of geology and so on. So if you're very interested in the Ice Age, that's a really good source. One that I've written just a year or so ago, Ice Cores in the Age of the Earth, is more or less a follow-on to that monograph, and it's a bit more technical in nature, trying to understand how we could get 2 miles of ice in the polar regions if that occurred since the flood. If the ice was not there before the flood, or if it was, the flood likely would have destroyed it or it would have floated away. How could you get that much ice accumulated in a few thousand years since the flood? So I'm dealing with the actual data, the cores that have been taken in Greenland and Antarctica, and it gets a little bit technical in one chapter, but the rest of it I think would be of interest to most anyone. There's a few other materials in the back table there I would refer to. One is a book that just came out by John Morris called It's a Young Earth, A Young World, I believe is the name of it. It's a monograph, soft cover-like book as well. And then there's a video that he just produced called Two World Views in Collision. And that one just came out about a month ago. And if you're interested in the issue of young people being almost brainwashed by evolutionary thinking in the public schools and how you can deal with that, you might want to purchase that particular video. It's only $9.95 for that particular video, and it's a really hard-hitting video dealing with what our young people are facing in the public schools, and even in some Christian schools. So you might want to get that and really look at it. It's very well done. It's done in a dramatic sense, and it's actually being used as our introduction to our Back to Genesis conferences now. You may be familiar with our Back to Genesis conferences that we have all over the country. And the way we normally introduce those is we invite the pastors in a particular city where we're going to have one of these conferences to come to a meeting where John Morris or one of our other leaders meets with them so that the pastors can get to know what we're all about and understand what we're thinking, what we're going to be teaching, because it's the pastor's responsibility not to expose crackpots or weirdos to their congregation. So this gives the pastors an opportunity to be able to see what we're all about. And we use this video as the introduction to the pastors, plus getting to know them firsthand. So I think you would really enjoy being able to see that video. From the background that you heard read a moment ago, you understand that my background is in atmospheric science. When I left the government a number of years ago and started teaching at Christian Heritage College, I was also involved at the Institute for Creation Research in the summer times doing teaching in the graduate school and doing research. One of the reasons that I got interested in creationism, in particular because my training specialized in weather modification and cloud physics. And I was always interested in what I consider the greatest weather modification event of all times, and that was the flood of Noah. And so I've dealt with the vapor canopy and whether it rained before the flood and what happened during the flood and so on. But recently I've gotten involved in the Ice Age and trying to understand how the climate could have changed since that time. And that's really what I want to talk to you tonight about, is what I call the Big Freeze, a biblical ice age. And there may be some ideas in here that you don't agree with, maybe you have not heard before, but at least it'll be a stimulus, I think, to our thinking and trying to understand how we fit the observations that we have that come from the polar regions into the biblical time frame. The first thing I need to do is to convince you, in fact, that there was an ice age. Even in my own thinking for many years, I was trying to deny the fact that there could have been an ice age, because coming along with the normal evidence for an ice age is the idea of hundreds of thousands or millions of years. So if there was an ice age that lasted, say, 100,000 years, and there was a number of those, multiples of those, maybe 60 of them, then automatically we have millions of years to contend with. And that's in direct violation or direct contradiction to what I believe is a literal interpretation of Scripture in a recent flood of a few thousand years ago. So I had to convince myself, first of all, that the evidence was valid. And I have done that, and so I'm going to try to show to you some of the evidences for an ice age here on the earth. There are a number of pieces of evidence that you can point to, such as mountain glaciers that are still in evidence in mountains, but appear to have been much greater in extent in the past. There is evidence that there were ice sheets that covered vast areas of the flat terrain, like in the northeastern United States and down through the Midwest and in places in Europe. Some of the evidences for these extensive sheets and glaciers are the detailed evidences of these kind of things moving, such as drumlins. mounds of dirt that were left behind as the glacier was moving along. Moraines, these are where the material was left behind as the glacier retreated, and the soil and rock that it kind of dug up like a snowplow left it behind as it retreated and melted. Kettles, these are places where ice was left in large chunks and left a void in the soil so that after it melted there was nothing there, so it's kind of formed a lake. If you've lived in the eastern part of the country, in Massachusetts, in the New England area, there's all kinds of kettle lakes they're called, and I'll show you a few pictures of some of these. Striations, streaks in the rock, whereas the ice moved across bedrock, it scraped and left distinctive marks in the stone. And then, most interesting, are something called erratics. These are rocks that were left behind, very large rocks and boulders that would be difficult to explain how they got there except by the movement of ice. And for many years people thought it was a result of the flood, but it appears that it was due to ice. In fact, that was the main thing that got the idea of an ice age started about 150 years ago. So let me go through a few of those evidences with a few pictures here to start with. First of all, you can go to mountains, the Rocky Mountains in particular, but mountains all over the world, and you can see evidences like this. Places where it appears that there was ice much greater extent than today, which eroded the rock and the soil in extensive areas in the mountains, leaving distinctive marks which it's not covered with ice and snow today, at least not permanently. In the wintertime in most mountains you'll get a light covering of snow, but it appears that it was much deeper, maybe thousands of feet deep in some of the mountains in the past that would leave those type of evidences in the mountains. One of the nearest locations that you can go and see this sort of thing is in Yosemite Valley. Probably everybody or most everyone in this room has been to Yosemite, and it turns out that the Yosemite Valley at one time in the past was filled with ice, maybe up to an elevation, something like that, and that the ice and snow that formed at higher locations to the east moved down the valley toward the west, ground up the soil and rock that was in the valley, and deposited it further west in the canyon. And in fact, the distinctive features like Half Dome, it actually ground away or broke away the face of Half Dome, and that's why it appears to have the shape that it does. After the ice melted, there was moraines left at the western end of the valley. If you've ever driven into the valley, you know it's kind of bumpy down in there, and it appears that there's all kinds of small pebbles and rock and so on that have been left behind. Those are called end moraines. And the walls of the canyon are vertical, actually U-shaped. The bottom of the valley is kind of U-shaped rather than a V-shaped, which it would have if there had not been a glacier moving down through the valley. And that these walls were left vertical so that the water that was coming from off of the higher elevation into the valley came to this vertical cliff and made waterfalls. That's basically why the waterfalls are as beautiful as they are in Yosemite Valley, is because of the action of a glacier moving down through that canyon. Now, it appears that the glaciers covered massive or extensive areas over the surface of the earth, particularly in the mountain regions, and they extended all the way from Canada down through the Sierra to the southern end, the Rockies all the way down through to Mexico, and at a higher elevation they were very extensive. It appears that glaciers extended to much lower elevations in the past than they do today. For example, the glacier that you're familiar with, the permanent glacier in Mount Rainier, extended all the way to the foot of the mountain in the past, up in that region. And there are evidences for glaciers even in the tropics. There's mountains right on the equator where apparently the glaciers that are there today, because of being at such high elevation, they were much lower, several thousand, 3,000 to 4,000 feet lower in elevation on some of those mountains today. And there's all kinds of evidence that this ice was much more extensive in the past. Well, if you're familiar with the Midwest, you also know that that part of the country was covered with ice sheets. At least that's what has been said. And some of the best evidence for that is to look at the moraines. This is a map. This is Lake Michigan. This is Illinois. And you can see what appear to be ridges of various types of soil that form continuous end moraines. And the glaciers, not glaciers, an ice sheet is a layer of ice that's more or less on flat terrain and moves very slowly. A glacier is a layer of ice on steep terrain, such as mountains, and moves fairly rapidly. But the ice sheet in the Midwest, which was on fairly flat terrain, as it melted back, well, as it was forming, it tended to squeeze out the soil beneath it to form these ridges, and as it melted back, it left them behind, forming these distinctive patterns. In fact, Lake Michigan and the other Great Lakes were actually formed by the ice sheets in that region. Now, the soil in this area, the glaciers were actually resting on soil there rather than on rock. So the material underneath was able to be squeezed out from under the ice, or as the ice moved, it actually plowed it up ahead, so you were left with these kind of moraines. Now, even today, you see that to some degree, although it's been eroded down, so it's much flatter now. So much of these features you have to actually look at by looking at the soil types and interpret it in that way. There still is involved in some interpretation in that. The striations I talked about, here's a good example where the ice was actually resting on top of bedrock. And because of the great weight of the glaciers and ice sheets, it actually would depress the soil and the bedrock by several hundred feet in some cases. But in cases where the bedrock was very thick, as it moved across, because of the heavy weight, it would scrape the rock. And underneath the ice, it quite often had small boulders and pebbles and rocks that it used like grinding stones underneath the ice, and that's what would leave these striations in the rock. And they form this very distinctive pattern. This happens to be in Nova Scotia, which you see is right close to sea level. As the ice went out into the ocean, then it floated and broke up into icebergs in the ocean, but it left these striations on the rock on land. Well, the last evidence that I will show here is probably the most distinctive, and that's the erratics that I was talking about. This is a stone, or actually a boulder. It's probably 30 or 40 feet in diameter, sitting right on the edge of this cliff, and it's of a different material than this cliff here is, and it came from a distance some 20 miles away. As a glacier or an ice sheet moves along, it grinds up the rocks that it comes in contact with, particularly as it's moving down through a canyon. Big boulders and rocks will fall off onto the top of the ice, and it'll get moved like a river for long distances. And if the ice is in fact several thousand feet thick and then begins to melt at the end of the, quote, ice age, it can leave rocks and boulders perched in very interesting places. We just went to Yellowstone National Park this last September and took a tour there of about 90 people. That's one of the things that ICR does, by the way. I meant to mention that earlier. We take tours to the Grand Canyon, Mount St. Helens, and now Yellowstone. And in a couple, 3 years, we intend to take a group to Israel. If you're interested in any of these kind of tours, we'd be glad to have you sign up on our Acts and Facts newsletter. You get that free of charge once a month, and it'll tell you about the plans for the future. Yeah.
Is the Israel trip going to deal with Israel itself?
No, it's going to deal with the geology of Israel, archaeology of Israel, and prophecy. Those are the three main thrusts of that particular tour. That was kind of a sidelight. At any rate, in the trip to Yellowstone,
the size of that rock?
It's on the order of 20, 30 feet in diameter. Very large size. When we were in Yellowstone, that's the reason I was getting to Yellowstone, wasn't it? On the north side of Yellowstone Falls, right near the canyon, Yellowstone Canyon, is a large erratic about this size. It's about 20 feet in diameter, and it's actually sitting in among the trees, and it's made out of granite, and it came from the Beartooth Range about 20 miles away. And the only way it could have gotten there would have been by a glacier. Interestingly enough, the canyon right next to where this erratic is located was not carved by a glacier moving down this canyon. So it's our contention, and one of the reasons we're going there is to do research, is to be able to show that this canyon was formed rapidly after the, quote, ice age, so that there was no opportunity for the glacier to cut out this canyon. The canyon is V-shaped, and yet here's an erratic sitting right on top of the lip of this canyon. So it's a really neat opportunity. You might look for the future of us reporting on that particular result. Well, anyway, these are evidences, and you find these all over the world. They're not few and far between. In fact, if you've ever been to New York City, right in the middle of Central Park are some erratics like this that were brought down from Canada by the glaciers. In fact, they have striations on them right in the middle of Central Park in New York City. Finger Lakes in upper New York were formed by glaciers moving down. Glaciers and ice sheets covered massive portions of the Earth. Now this is kind of a view of the northern hemisphere of the Earth to give you some idea what the coverage looked like on the entire Earth. You can see, for example, glaciers and ice sheets covered the Alaskan Peninsula, down along the coast of Alaska, into the northwestern United States, into the Seattle-Tacoma area. In fact, Mount Rainier was covered with a glacier, and the Seattle-Tacoma area was completely covered with ice about 2,000 feet in that Puget Sound area at one point. The whole region along here in western Canada was covered. This doesn't show it very well, but the glaciers obviously formed down through the Sierra and down through the Rockies at the high elevations, but this is the more broad coverage of ice sheets and glaciers. There was a tendency for a narrow region in western Canada to the east of the Cascades and the Sierra for there to be a boundary there where there was not much of an ice sheet. But from that portion all the way east across Canada it was covered, down into the central United States, through central Missouri, central Illinois, Indiana, Ohio, that whole area, up across to the New England area, Maine, Nova Scotia, all those islands out there were covered. Greenland, England was covered, northwestern France, Germany, across Sweden and Norway, and northern Asia. That was all covered with ice sheets. The North Atlantic and most of the North Sea, or the ocean around the North Pole, was all covered with an ice shelf at one point in the past, as far south as 45 degrees latitude. Now that's basically a line between Boston and France. There was an ice sheet that covered the North Atlantic down that far. Now the evidences for that are from the boulders and debris that was left on the bottom of the ocean at the edge of that particular shelf of ice. Now that has rather significant consequences, it turns out, on climate and weather, which is what got me interested in this whole thing. Well, the question then is, what forms an ice age? What is the requirement to be able to have an ice age? It turns out that there are two basic requirements. One is that you have to have greater snowfall, but believe it or not, more importantly, is that you have cooler summers. That is, that you don't have a summer where the ice and snow melts in the summer, so you have to start all over again with a snowpack the next year. If you have a lot of snow and ice in the winter and then it all melts the following summer, it's never going to continue to accumulate. So somehow you have to be able to accumulate it. Now this is a little bit technical. This is probably the more technical part of the talk, but you need to understand this a little bit to grasp the problem with the standard explanation for the ice age. This is a diagram to show you how much water vapor the air can hold as a function of temperature. And let me describe the diagram a little bit, and then I'll tell you what it means in a little bit easier language. Along this axis here is temperature in degrees centigrade. You knew you were going to have to get metricated sometime, right? In degrees centigrade. 0 degrees centigrade is the same thing as 32 degrees Fahrenheit. That's the freezing point. And colder than that goes down to minus 40. And it's easy at minus 40 because minus 40 is the same in centigrade or Fahrenheit, so it doesn't matter there. But as you get warmer, you go to the right. If you get colder, you go to the left. The vertical axis is the water vapor capacity in grams per cubic meter that air can hold. And it goes from 0 down here, or very close to 0, and increases upward. The point of this diagram is that as you increase in temperature, the amount of water vapor that the air can hold goes up exponentially. It goes up dramatically, very, very rapidly. But it does turn out that when you get cold, the air can't hold very much water vapor. Now that's the problem if you're trying to explain an ice age by the fact that the Earth just got colder. If the Earth is colder, the air can't hold much water vapor, and therefore it can't produce much snow. There's an old adage that you may have heard. It's too cold to snow. How many of you that have been from the Midwest or the northern part, you've heard that? Yeah, right. Well, it's actually literally true. If it gets down to around minus 30 or minus 40 degrees, it really can't snow. I mean, you can get little bitty snowflakes, little bitty ice crystals. In fact, it produces diamond dust up in the mountains. I've seen that, but just doesn't do much. So you have to have relatively warm temperatures in order to be able to get a lot of snow. Well, that's somehow in contradiction. And in fact, that's been the difficulty with much of the modeling effort that's been done by the standard community in trying to understand the ice age. This is a modeling result by a fellow by the name of Williams, back in 1979, and they haven't had much success since then. This is the best they've been able to do with the models of the Ice Age, trying to show how you can get a permanent snowpack. They've been able to successfully cover Greenland with some ice and snow, and the northern part of Canada, but as far as they can go is at the southern end of Hudson Bay. That's as good as they can do in terms of a permanent snowpack with a climate that's similar today by making it colder or whatever they can do. They cannot get an ice sheet to move down into southern Canada, let alone down into the central United States. It just won't do it by the modeling. And the basic reason is because there's this major conflict. If you have the conditions that are similar today by making it colder, you don't get an ice age. I mean, it gets colder, but it doesn't produce any snow because of that problem. I lost a diagram here. Oh, here we go. Well, no, I'm sorry, that's later. Well, it turns out that there are a whole bunch of theories that have been proposed for an ice age, or the ice ages. The standard view for many years was that there was 4 ice ages. You've probably seen in the museums how there was 4 ice ages. Today, the idea is that there was some 60 ice ages, each lasting about 100,000 years with about a 10,000 year interval between the ice ages. Well, there's a number of attempts to try to explain how these ice ages develop, and I'm not going to go into these in a lot of detail, but basically one is that for some reason there was a decrease in carbon dioxide. You've heard of the greenhouse effect. You increase the carbon dioxide, it causes the atmosphere to warm up. Well, the opposite would be true. If you take away carbon dioxide, it gets colder. That might lead to an ice age. The problem basically with this idea is that the evidence shows that the ice age occurred before the decrease in carbon dioxide occurred. So if the carbon dioxide is the cause, that wouldn't be an explanation for it. So that didn't work out very well. Another one has been suggested that when volcanoes go off, they throw a lot of dust and particulates and gases into the atmosphere, which causes the atmosphere to cool, leading to an ice age. Well, it is true when volcanoes do go off that they cause cooling. We've seen the effect from El Chichon in Mexico, Mount St. Helens, and other volcanoes that have gone off. We even have evidence in some cases that the cooling is as much as 2 or 3 degrees over a period of several years after the volcano goes off. It leaves all this dust and material in the upper atmosphere, which reflects radiation to space and causes cooling. But the basic problem with that is you'd have to have massive volcanic activity over a long period of time to kick off an ice age. So, they're trying to look at something that would happen cyclically. Every 100,000 years you'd have an event like that. So it's not been a very good explanation, although it does have some value. Another suggestion has been the Arctic Ocean being ice-free. Today there's covered with a thin layer of ice. If the Arctic Ocean didn't have an ice layer on it, it would evaporate a lot of moisture into the air, which would provide the source for the snow and ice to form the ice sheets. But what would cause the Arctic to melt? So there's some problems there. Another one, very interesting, in the southern hemisphere, they're suggesting that the ice sheets on Antarctica from time to time lift off of the continent and float out into the ocean, break up, and cover the southern hemisphere with a lot of ice, which reflects the light and causes cooling. That in turn would affect the whole Earth. Well, that has a nice idea because it happens cyclically, it appears. Somewhere around 2020, they're expecting a major portion of the Antarctic ice sheet to break loose and drift out into the ocean. But they don't have any evidence that that's happened in the past, but this might happen in the future, so they're projecting backwards. Well, those are called terrestrial theories, ones that things here on the Earth would cause such an ice age. There are such things as extraterrestrial theories as well. For example, maybe the sun gets cooler or doesn't put out as much light from time to time. The problem with that is all the evidence that we have is that the variation of the sun is very, very minor. We've seen variations in sunspot cycle, but the percentage of decrease in solar radiation is extremely small. It's like less than 1/10 of 1%. So you wouldn't expect that to result in an ice age. Is it possible that as the solar system moves through our galaxy, we move into places where it's more dusty than in other places? And that would cut down on the light coming from the sun to the Earth. Well, that's fairly conjectural. There is dust out there, but we don't have any good evidence for that happening in the past. Another one might be meteoritic bombardment. Meteors coming from space and impacting the Earth, such as the meteor crater in Arizona. When one of these hits, if it's fairly sizable, it throws up tremendous amounts of dust into space around the Earth and would lead to cooling. It's likely that it would lead to cooling, but is that cyclical? Not good evidence for that. Well, it turns out that the theory that is currently in vogue and is generally used to explain the Ice Age is something called the astronomical theory. It was developed by a fellow by the name of Milankovitch back in the 30s. He published in 1930 and 1941, and he correlated the evidence that was coming from seafloor sediment, variations in seafloor sediment, with the orbital parameters of the Earth. And this is a little bit hard to describe, but let me give you a little bit of an explanation. It turns out when the Earth rotates around the sun, now I hope I don't insult geocentrists here, but this is the view I happen to hold to, so bear with me. As the Earth is going around the sun, it's sitting on an axis of rotation, and it's very much like a gyroscope. As it goes around the sun, its orientation stays fixed, fairly fixed in space, and it is in an orbit around the sun that is elliptical. But it turns out that there are three measurable changes in that situation. First of all, the Earth on its axis, spinning on its axis, tends to wobble just a little bit. It turns out that this elliptical shape of the Earth's motion around the sun changes from elliptical to circular, or almost circular, and then back to slightly elliptical again. And the seasons for when the sun, like for instance the summer solstice is out here at the end of this ellipse, that tends to rotate around this ellipse. Those three motions have a period, based upon the measurements that we can make today, of 20,000, 40,000, and 100,000 years. Now what's been done is to take those periods and correlate those to data coming from seafloor sediment. Turns out there's little microorganisms called forams that grow in the ocean, and when they die, their shell sinks to the bottom of the ocean and they form layers in the bottom of the ocean. It's made out of calcium carbonate. And when you measure the carbon dioxide or the carbon that's in the oxygen that's in those shells, you can relate that to the temperature at which they grew in the ocean. Since it's layered, they have found layers that appear to have variations over periods of 20,000, 40,000, and 100,000 years. So they think that they were caused by the changes in the radiation coming from the sun to the Earth because of the changes in the orientation and so on. That changed the temperature of the ocean, leading to this changes in the sediment in the bottom of the ocean. Now it turns out that there's some major problems with this particular theory. First of all, it's completely statistically based. It is not physically oriented at all, and it's statistically not very good for this particular reason. It turns out that the attempt is to explain the ice ages, which they think occurred every 100,000 years, but the weakest change in the orbital parameters of the Earth, the weakest one is the 100,000 year one. That's the one that you would expect the temperature of the ocean to change the greatest, and it turns out to be the weakest. So there's a major problem with this particular theory. Even the people in the field are uncomfortable with it, but it's the best explanation they got, so that's the one that they have adopted. Well, I think we have a better explanation, which is what I'm going to turn to next. But let me give you a quote from Mike Ord first, related to these various theories. And I've only given you 8 of them, the astronomical theory being the main one that's explained today, but there's some 60 or 80 different theories on the ice ages. When you got that many theories, you know you got a problem. Mike says, in summary, the proposed solutions, or theories as we're saying here, cannot provide the sustained cooling and the heavy snow to glaciate northeastern North America under essentially uniformitarian conditions. Basically, the astronomical theory or all these other theories is assuming that the climate of the Earth is fairly uniform and has very minor changes that would lead to an ice age. None of these theories can adequately explain the evidence we have for massive glaciation of North America or Europe or even in the southern hemisphere, which we haven't even talked about. They just can't do it, and the modeling has not been successful. Well, let me give you an alternative model, what I consider a biblical model of the ice age. And I'm going to talk about such things as volcanic dust, a lot of cloudiness, barren land surfaces, reflection from a lot of snow cover, variations in carbon dioxide, storm tracks that tend to remain in fixed locations, and high ocean evaporation. Think about it this way. What is your view of what the flood was like? Do you think of it as being a fairly calm, quiescent event? Over the years that I've thought about what the flood was like, and as I've learned more about geology and I've learned more about climate, learned more about the events that probably went on, and went back and looked at Scripture in more detail, each time I do so, I come to the conclusion that the flood was a much more catastrophic event than I had thought it was before. There is a number of us at ICR and other places that are working together, and we reported at the International Conference on Creationism last summer before last in Pittsburgh on what we call a tectonic flood model, in which we are putting the various pieces together, the geophysical pieces together, to help us to understand what may have happened during the flood. We don't believe that the flood was just a calm event where the water went up, covered all the land, and went back down again. It was a very catastrophic event. And it appears that the thing that initiated the flood may have been a piece of the crust of the earth actually broke loose from the bottom of the oceans and dove into the mantle of the earth. It actually broke loose and dove in and is now resting on the core of the earth at the bottom of the mantle. When it did so, it broke the crust of the earth in fragments in such a way that it actually ripped the continents apart, separated them from what we believe was one gigantic continent to start with, into various pieces as we recognize as the continents today. In doing so, this piece that dove into the mantle of the earth actually broke the continents apart and broke the ocean floor apart in the middle, and where it was broken apart, the hot magma in the mantle resurged up into the middle of the oceans, forming the mid-ocean ridges that we find today. I keep meaning to add a picture to my talk here showing you a distribution of the mid-ocean ridges. You may have seen one of these in an atlas, where all over the surface of the earth, under the oceans, is this gigantic mountain chain. Right down through the middle Atlantic. There's one that goes all the way through the Atlantic. There's one that goes out through the Pacific, out into the Persian Gulf, under the continent of India. These mountains are on the order of several thousand feet high and several thousand miles wide, that apparently this material came up, it was very hot, and then separated. Now the standard view today is that this material is going on today very slowly, forming like a conveyor belt. You've probably seen these in the museums. We believe that this happened during the flood, very rapidly in the year or so during the flood. In that process, near the continental boundaries where this plate was diving down into the mantle, it actually submerged the continents, because they're kind of like floating on top of the mantle. As it dove in, it actually depressed the continents to a certain degree. In the middle of the oceans where this hot material was coming back up, it raised the bottom of the ocean to a certain degree and actually caused the water to flow onto the continents. So they covered the continents completely. All the mountains were covered, the Bible says. As it did so, it took all of the sediments and ripped many more loose and threw them onto the continent. Actually flooded the continents, bringing sediments in, marine organisms and all kinds of things, and buried them, which formed the fossils that you find on the continents today. Near the end of the flood, as the continents began to rise back up on top of the mantle again, and the middle of the oceans cooled and began to settle down, the water came back off the continents back into the oceans, and eroded much of that material back out into the ocean and left the sediments right along the edges of the continents. Well, in that process, you had earthquakes and tidal waves, you had mountain building, you had forests being destroyed, all kinds of erosional processes. You had magma being in direct contact with the oceans. Can you imagine the amount of heat, both from frictional forces and direct thermal heat, that would have been resultant at the end of that flood? That, we believe, is the main source of the Ice Age. That the oceans actually retained a tremendous quantity of heat at the end of the flood, and left them considerably warmer than they are today. And it took 1,000 or more years for the ocean to slowly cool back down, and during that time when it was warm, it was a tremendous source of evaporation of water vapor into the atmosphere, which could then produce precipitation in the form of snow in the polar regions. During the flood itself, we know that the windows of heaven were open and the fountains of the deep were broken open. But the Bible says it the other way. It says that the fountains of the deep were broken open first, and then the windows of heaven were open. So it may be that the fountains of the deep was all this motion going on in the mantle, and then the fountains or the windows of heaven were the resultant water vapor being formed, condensed to produce rain. Now, the assumption here is that the rains and the snow did not stop immediately at the end of the flood. It probably did in the equatorial region, in the central part of the globe. But in the polar regions, it probably went on for 700,000 years or so after the flood. In fact, I'm going to show you a map in a few moments showing you some of the distributions of that from some of the modeling studies we've done. Well, it's likely that after the flood, you had continual cloudiness for long periods of time. In fact, if the oceans were left as warm as we think they were, in fact, I'm kind of warm right now, if you don't mind. You know I own one, so I'm going to take it off, right? After the flood, it's likely that because the oceans were very warm, they would have formed gigantic hurricanes. This is one of the hurricanes that the Apollo program photographed back in 1968, Hurricane Gladys in the Gulf of Mexico. Some of the data that I have shows that there would have been giant hurricanes that would have been formed under these kind of conditions and could have continued devastation for many years after the flood in certain places on the earth. The significance of being cloudy like that, though, is that it would have reflected a lot of radiation back to space, and over the continental regions would have made the continents very cold. In addition to that, the surface of the earth would have been very barren right after the flood. Have you ever thought about what the surface of the earth would have looked like when Noah got off the ark after the devastation that I've just described? This is probably what it would have looked like. You wouldn't have seen forests, you wouldn't have seen trees, there wouldn't have been much vegetation of any kind, maybe a few trees sticking up out of the ground somewhere, maybe a few that floated on the ocean kind of got grounded somewhere, but by and large it looked like that. Now that actually is a picture of Mars, so don't get too carried away. That's not Arizona. But this kind of condition over the continents would have led to tremendous cold temperatures over the continents. It turns out grass and trees and all kinds of vegetation moderate the climate dramatically over the continent. But if you have bare land like this, it's going to be very cold. So here is likely what happened. We have warm oceans with very cold continents. And that's going to set up a whole type of different climate and wind regime and cloud and weather patterns than what we have today. If in the polar regions you had some of this precipitation beginning to form as snow and forming vast areas of snow, the snow cover itself reflects radiation to space very effectively, causing it to cool even more. If you've ever gone skiing, snow skiing, or even water skiing for that matter, but snow skiing in particular, you come back and the bottom of your chin quite often is sunburned. It's because the light hits that and reflects right back up again. And at night, it's very effective at emitting the radiation to space and causing tremendous cooling as well. So it's a good feedback mechanism where once you start to produce snow cover, it even cools the surface more. One of the things that the flood did was to kill most of the life on Earth. The only thing the flood did not kill was Noah and his family and all the animals on the ark, and much of the seagoing life, fishes and other animals that lived in the oceans. Now, many of those were killed too, as we know, because there's so many marine organisms that got buried in the sediments. But much of the life was buried. That would have drastically affected the carbon dioxide balance in the earth. In fact, the temperature of the ocean and the burying of so much life on the surface of the earth would have changed the carbon dioxide balance in the earth. So it's no wonder as we look in snow pits and at cores in the earth and we look at carbon dioxide levels, they're going to change dramatically. Not because they caused the ice age, but because a result of all this burial of life on the earth and the changes in the ocean, catastrophically. Let me say a little bit about constant storm tracks. If you have a warm ocean, which Mike Ord has suggested was on the order of 30 degrees centigrade, something on the order of 90 degrees Fahrenheit, and the continents were very cold, they would tend to form the coldest regions in the middle of the continent, forming this pattern of isotherms, where it gets warm and cold toward the middle of the continent. Meteorologists know that this is an ideal situation where storm patterns tend to want to follow along parallel to these isotherms. In fact, any storm that forms would tend to want to follow along. Well, let me show that previous one here first. Would tend to want to follow along. A storm that would form here would tend to want to follow right along this way and right up the East Coast. If you've ever lived on the East Coast, you've probably heard of nor'easters. These are storms that tend to intensify. They start down in the southeastern United States, move up the coast, and as they move, they tend to get stronger and stronger. They can get very large sometimes, and the circulation pattern around a storm low like that causes moisture to be brought in off the ocean and dumped onto the continent. In fact, if you look at that kind of a storm in a cross-section looking from south to north, say from Georgia toward New York, here the ocean to the right, the land would be to the west, ocean to the right, land to the left. The storm would actually draw warm moisture off the ocean up at front and dump it as snow or rain onto the continent. And you can quite often get 6 inches to a foot out of a particular storm like that. If this happened day after day, you could dump a lot of snow in a hurry in the northeastern United States. Those are some of the ideas that we're suggesting from this model. Now let me give you a few other evidences, and I'm probably 10 minutes, 15 minutes away from taking a stop here so we can open it up for questions. But let me give you a few other results of such a model. First of all, if this is actually what happened, we would expect to see the oceans, the evidence for the oceans cooling off with time, and I'm going to show you that in a moment. We would not expect the volcanism, the volcanoes going off, to just stop abruptly at the end of the flood. We would expect them to decrease slowly, and in fact, that turns out to be the case. We would expect the ice sheets to grow to large regions and then decrease again, and we have evidence for that. I'm going to talk a little bit about land bridges. That is, I'll leave that for a moment. Pluvial lakes. These are lakes that farm out in dry desert regions that were much fuller in the past than they are today. We have evidence for that. Wet deserts. And how about woolly mammoths? We can see we can bring that in a little bit on it as well. Okay, the first one I'll show you here is a piece of evidence that I published in Acts and Facts about a year ago, which is really quite exciting. This is the data from seafloor sediment where we interpret these little shells from these foraminifera I talked about, and we can estimate what the temperature of the ocean was based upon the carbon and the oxygen concentrations, and particularly the oxygen in these shells, oxygen 1816 isotopes. We can interpret the temperature in the time past, and I adjusted this for the time frame, a biblical time frame. The standard interpretation, which you find in the literature, is that this data goes back to the Cretaceous period when the dinosaurs supposedly roamed the Earth some 65 million years ago, and the data shows that the temperature decreased kind of linearly with time over 65 million years by about 15 or 20 degrees centigrade. But if you compress that time and assume that that layer, the Cretaceous tertiary boundary as it's called, you may have heard of that, if that happened at the end of the flood, which I believe it may have, if you compress that into a biblical time frame of about 4,500 years since the flood, this is the kind of temperature trend that you get. Starts off about 20 degrees centigrade or thereabouts and cools down to the ocean temperature that we have today. And if those engineers in the room, you'll recognize that as the type of temperature trend that you would expect from a cup of coffee cooling off. It cools off very rapidly at first and then slows down as it approaches the room temperature. Only the difference is here, this is over a period of 1,000 or so years, and this is directly out of the evidence from the seafloor sediment. So I believe that we have evidence showing that the ocean cooled following the flood. This is a diagram showing the importance of volcanoes. I don't have any good evidence for this at this point yet, but the idea is that the volcanoes continue to spout out material which left this particulates in the atmosphere, which would have led to cooling over the continents. We don't have to worry about the oceans cooling because they are providing the source of heat. They are the source of heat and moisture, but over the continents, it would provide the cooling. So as the moisture comes out of the ocean, that would have provided cooling over the continents. Now, here's a result of some of the modeling studies I've done, and those of you that get Acts and Facts, you may have seen this about a year or so ago. And I'm going to have to correct something for you here. I did correct it in Acts and Facts, but we made a mistake in interpreting the output from this. But let me tell you what we've got here. This is a map of the surface of the Earth in a Mercator-type projection. This is longitude, and the longitude here is at 0, which would be at England, going around the Earth to 360 degrees back to England again. This is latitude with the equator here in the middle, north latitude up to the North Pole, down to the South Pole. You can actually see the continents on here. Here's Africa, Australia, Asia, North America, South America. Imposed on this are contours of precipitation rate in millimeters per day. Now, originally when I published this in Acts and Facts, it was feet per hour. And it turns out when we discovered that we had interpreted the output from the model that we were using, and it adjusts it downward significantly. But even the units here are on, the yellow area is more than 5 millimeters per day. The boundary of the red is 10 millimeters per day, and it goes up as high as 40 millimeters per day, which is on the order of about 2 inches per day of precipitation up in these high precipitation areas. That rate is still enough, on the order of an inch per day, to accumulate 2 miles of ice in Greenland in a period of about 500 years. Now, the significance of this is you'll notice that in the equatorial region, there's very little precipitation. In the polar regions, there's a lot of precipitation, and also along the boundary of the continents. Now, the conditions for this, I should have said this earlier, what this is a simulation of what precipitation you would expect if you had the ocean temperatures at about 90 degrees Fahrenheit worldwide. So what we've done is I said, let's assume that we have a lot of heat that was left over from the flood. It was distributed in the oceans of the world. It left the oceans warm at about 90 degrees Fahrenheit. What kind of precipitation would you get? If you use today's condition, you don't get any precipitation at all with these kind of contours. With the 30 degrees centigrade or 90 degrees Fahrenheit, this is the kind of distribution of precipitation you get. What you see gives you a lot of precipitation in the polar regions and very little in the equatorial region. Of interest to me was what would happen over around where the arc was. Here's the Mediterranean. The arc would have been located right about, would have been right up in this area in here somewhere. So that as Noah got off the ark, one of the reasons he had to leave the ark was it was up at a high altitude, and it was probably getting cold and windy and snowy up there, and he had to move southward down into the Tigris-Euphrates River Valley, which you notice doesn't have much precipitation. In fact, it was fairly easy for him to move southwestward or southeastward or directly eastward in a relatively dry region. But in the Tigris-Euphrates Valley, it was still very nice and moist and probably nice and grassy because there was lots of snow and precipitation in the mountains to the north, which fed down into that valley. So there's really an interesting sociological or cultural issues in terms of the migration of peoples with this kind of precipitation distribution. The main significance of this, however, is it appears we have a way of being able to explain how the ice sheets accumulated in Greenland and in the mountainous areas. Now, what would happen if this went on for 500 or 700 years and you accumulated 2 feet of snow in Greenland and 2 miles of snow in Greenland, 2 miles of snow in Antarctica, all this snow and ice on the continents and in the mountains? It turns out that water has to come from somewhere. It came out of the oceans. There is evidence that the oceans were as much as 300 to 400 feet lower in elevation than they are today. In other words, the water was taken out of the ocean, formed snow and ice, and was on the continents, and the ocean level was lower. Here's an example what would happen if that was the case. This is the Bering Sea or Bering Strait between Alaska and Russia, there is a region in here where the water is only about 150 to 200 feet deep. If the ocean was 300 feet lower than it is today, this whole area would have been completely open, and people could have walked across there, animals could have come across there. Turns out that there's a region between Southeast Asia and down toward Australia that's very similar. It wouldn't be a continuous land bridge, but there would have been little islands that would have dotted across there, and much of that would have been land down to Australia even. So there's some very interesting features. For example, Florida, which has that distinctive shape today, the water level would have been down 300 feet lower, and it turns out most of the Gulf of Mexico would have been land. You could have walked on the Gulf of Mexico. In Florida, you wouldn't even recognize the shape of it because the water would have been so much lower. Because of the way the weather patterns existed, it's likely that the southwestern United States was much wetter in the past than it is today. That much of the lakes that are dried up out there, if you've driven across Utah and Nevada and Arizona, you've seen places where, you know, it's very flat and it looked like it was a lake bed at one point in the past. It actually was. Death Valley was full of water at one point in the past. Did you know that Salt Lake, which was called Lake Bonneville in the past, was over 1,000 feet deep? It's only 15 feet deep today. As part of our Yellowstone tour, we took people to the north of Salt Lake City, about 75 miles, and we showed them where there's a gap in the mountains where Lake Bonneville broke through, and it produced the world's third largest flood after the Genesis flood that's ever occurred on the surface of the earth. Lake Bonneville went from 1,000 feet to a little over 500 feet in a matter of a month or so, and all that water drained out of Lake Bonneville into the Snake River to the north. Tremendous devastation down through Pocatello. Lava beds washed out and so on. At any rate, where did that water come from? It probably was trapped as the continent arose and the ocean water was left in that basin. But in addition, during this ice age, I'm calling it the ice age, there was a lot of precipitation and snow that fell in the mountains and drained into that lake area, so that it didn't break loose until after the ice age. And there's a lot of other lakes all through, particularly Nevada and Utah, that we believe were well watered because of the climate being different right after the flood. Well, I'm going to leave this fellow for questions a little bit later. We got some ideas on mammoths, how they got frozen out. Now, let me give you an illustration. If you think this is all hogwash, or really it's not possible to accumulate 2 miles of ice in Greenland or Antarctica, let me illustrate how today we can still accumulate a lot of ice and snow in regions if the conditions are right. Some of you may have seen this. A fellow by the name of Pat Epps out of Houston, Texas, had a major dream. He wanted to recover some World War II vintage aircraft that crashed on the southern coast of Greenland. And about 5 years ago, he put together a team, and they went looking for these airplanes. There was a squadron of 6 P-38s and a couple of bombers. I forget what the kind of bombers were now. B-17s? No. I forget what the bombers are. There's a couple of bombers anyway. I'm sorry, P-51s. P-51s and a couple of bombers that crash landed on Greenland. What happened was it was right near the end of the war, and they were taking off from the United States to head to England. It was in 1945 or somewhere about there. And when they left the northeastern United States, they got halfway across the Atlantic, and the stations in England were socked in. They couldn't land, so they turned around and headed back to Nova Scotia or the northeastern United States. They got socked in. They couldn't land there, so they ended up going in circles for a while there in the middle of the Atlantic near Greenland, and finally ran out of fuel and had to crash land on Greenland. Everybody got out okay, but there was all these planes sitting there on Greenland. They were rescued about a week later, but they left the planes there. Well, Pat Epps heard about this, and he decided to go recover those planes. Well, he went looking for them with metal detectors of various kinds, and he finally located where they were, but he was astonished to find out that they were 200 feet deep in ice. There had been 200 feet of ice and snow had accumulated in the 50 years since they had crash landed on Greenland. This is back in 1993, so it's 50 years later. So there was an average of about 4 feet a year. I'm sorry, it was 250 feet of ice. So it was about 5 feet a year of ice that accumulated. Now the reason it accumulated so much ice and snow there was right at the southern tip of Greenland is where the Gulf of Mexico the current comes up from the Gulf of Mexico, which is very warm, right next to this very cold climate on the southern tip of Greenland. So you had the ocean providing all this moisture and immediately dumping the snow right on the coast. Well, let me show you some pictures here to show you what happened. They designed a system called the Gopher, where they were going to drill holes down through the ice. They had to go 250 feet down. They designed a cone in which they wrapped some copper tubing around it, which they ran hot water and steam through, and they just laid it in the snow and let it work its way down through the ice. And it bored out these big holes that were about 6 feet in diameter, and then they had to dig out the space in between, kind of let themselves down. You see he's kind of on a chain there because that's a 250-foot deep hole. And this is what they found when they got down to the bottom. Here's the P-51 down in the bottom. They took hoses down there with steam on them and melted out the snow, took the planes apart, and they got one of them out. I don't know if they're working on the others or not. Now, they're worth several $1 million apiece, so that's why they're well preserved and everything. But there's evidence, even today, that you can accumulate as much as 250 feet of ice in 50 years if the conditions are right. Now, this is a large-scale area on the southern coast of Greenland. Well, let me just come to a conclusion here, and that'll allow us to have some questions. First of all, I hope I've convinced you that there was an ice age. There were extensive ice sheets and glaciers at some point here in the past in Earth history, but I don't believe it was over periods of millions of years. It turns out that the models that are attempted to be developed to explain the ice age over these hundreds of thousands or millions of years are inadequate. They do not explain how you get an ice age. There's all kinds of major problems with them. And I think the reason is you need a catastrophic model in order to be able to explain the ice age. Something major had to be the source of energy to produce an ice age. We think that the biblical model fits it well, that the flood was this major source of energy, that all the catastrophic events that occurred during the flood left the ocean in a warm condition, which was a source of moisture for the production of precipitation, particularly in the polar regions. We think that this is a unique opportunity for we creationists to be able to develop an alternative model and to be able to present it in a way that I think will be acceptable eventually, but it'll be a catastrophic model. You may or may not be aware that today catastrophic models are having a revival. It turns out that many standard scientists in the scientific community are turning to catastrophism to explain the observations that they have. They still resist the flood and biblical catastrophism, but they are being forced to consider catastrophic explanations. This, I believe, is the explanation for the Ice Age, because there is no explanation for the Ice Age as it currently stands. Thank you. Okay, you want to go ahead with questions and answers? Okay. Yes, sir.
Could you give some of the details of the ice core data as far as what you have found in there?
Okay. He asked a question that can I give a little detail of the ice core data. Here's a picture of an ice core, by the way. This is one of the cores that was taken from Greenland. That's what they look like. They're about 6 inches in diameter, a little less, and they're on the order of 2 miles long. They take them out in sections about 30 feet at a time and then store them and then analyze them. There is all kinds of data in these ice cores, such as particulates, such as carbon dioxide concentration. You can actually see some of the layering in this core having to do with some of the biologic material that's gotten trapped in the ice and snow, and it changes the color at various layers through the ice. Probably the most interesting variable that is measured for my interest is the oxygen 18-16 ratio. This is the concentration of oxygen. Obviously the ice core is made up of ice, which is water, and so therefore it has oxygen in it. And it turns out that the percentage of oxygen 18 isotope relative to the oxygen 16 isotope can be used to estimate the temperature at which the ice was formed when the precipitation occurred. So you can infer something about the temperature of the climate when the snow was laid down. I don't think I have a diagram here. Let me look real quickly. Maybe I do. No, I don't. There's a trend of the oxygen-18-16 ratio, which has a very distinctive shape to it. It's almost sawtoothed as you come from the bottom. The oxygen-18-16 ratio, which implies a very warm temperature when it's high, is a high value, and it decreases as you get closer to what they consider 10,000 years ago or so. It gets its minimum at what they consider the coldest period of the Ice Age, and then suddenly it goes up and then stays at that constant value as we observe it today. Kind of a sawtooth shape, kind of like that. There's also a lot of other variation in it. But that particular trend is interpreted as when it's warm, that was back before the last Ice Age started, it was relatively warm, and it got colder, and then suddenly the Ice Age ended, it got warm, and then stayed uniform for the last 10,000 years or so. I believe I have an alternative explanation for that, and I have a student working on it now. I believe that the trend is not so much related to temperature as it is the coverage of the North Atlantic by the ice shelf as it moved from the polar regions southward down to 45 degrees latitude. And that affected this ratio of oxygen 18 to 16 in a trend, so that when the Ice Age came to an end and the ice all melted, that ice sheet disappeared, and that trend moved it back up to this level very quickly. I'm not explaining that very well. That's a whole talk in itself. But I have a student who is working on that particular project right now. I've got the explanation. He's going to prove it for me. We'll see. Yes, sir.
Is it either 16 or 18, or does it go?
No, it's the ratio of the two. It's the ratio of, actually it's called delta oxygen 18-16. What it is you take the ratio of oxygen 18 to oxygen 16, and then you take the difference of that ratio from what it is in standard ocean water today. And it's a difference in that ratio then as compared to today.
Could there be oxygen 17?
I don't know of oxygen 17.
That was my question.
Oh, I see.
Does it come down, or is it either 18 or 16?
No, it's 18 and 16. The reason those are important, it turns out that oxygen 16 is evaporated more readily from the surface of the ocean than oxygen 18 because it's a little heavier. It's kind of separated. That's why you ended up with what's called a fractionation of those two isotopes. And that turns out to be related to the temperature. That's why it's significant.
How would the temperature of the water affect like the sea life and food chains? Because a lot of those are dependent on temperature.
Well, that's a very interesting question, and I'm not the person to really answer that. And in fact, it's a bit of a concern for me. First of all, the question would be, how could any sea life at all exist if the whole ocean is 90 degrees Fahrenheit? It turns out that a lot of sea life can exist at that temperature. And in fact, much of the ocean today down in the tropics is at 90 degrees Fahrenheit even now. It even gets warmer than that. And most of the sea life is up near the surface of the ocean. The upper 300 or 400 feet is where most of sea life lives, because below that the sunlight can't penetrate and it's dark down there and it doesn't have the nutrients. But so a lot of sea life can, but some can't. So the question is, can the whole ocean be warm or not? I don't know the exact answer to that, but I got two provisos. One is that I believe that the ocean was warm where these ridges occurred in the middle of the oceans, and that affected the surface temperature, but the whole ocean may have not been that hot. With time, it may have slowly warmed the ocean, but may have not got it that warm everywhere. Another thing is that while this was going on, you had water and precipitation producing runoff off the continents, which would have been fresh water, which came off the continents onto the ocean and would tend to float on the top of the seawater, the salt water. So you would have had a lens of fresh water on top of the ocean, and it would have tended to, in places at least, to be relatively cool because it's coming off the continents out of the river, from the rivers. So a lot of the sea life, if it could not live in these warm temperatures, could have migrated to places where the water was cool, particularly at the mouths of rivers coming off the continents. So there may have been places for the sea life to be able to exist. One of the fascinating things, I think, that relates to carbon dioxide is that my impression is that the flood produced a tremendous amount of leaching of the material. You know, when it ground up all the rocks and produced sediments, the ocean leached out a lot of salts and all kinds of nutrients. There would have been all kinds of material left in the ocean, and it would have been completely mixed up because of all the catastrophic nature of the flood. And then it was left relatively warm. This would have been an ideal situation for micro, protoplasm and all that to grow, and the food chain would have been augmented so that you probably would have had a tremendous bloom of all kinds of microorganisms, other sea life that eats on the lower food chain, all the way up to sea monsters. It's my guess is that the oceans were absolutely teeming with life several tens or hundreds of years after the flood because of this influx of nutrient and warmth, and it's very likely that these reports that we had of hundreds of years ago when the sailors went out with all kinds of monsters in the ocean, those were probably there because of having the whole ocean bloomed in all kinds of ways. That would have affected the carbon dioxide concentration. It turns out that when you grow plants, let's see, which way is it now? The plants absorb oxygen and give up carbon dioxide? Or
Take in carbon dioxide for photosynthesis.
That's right. They take in the carbon dioxide and give off the oxygen.
Right.
So you could have had tremendous changes in carbon dioxide concentrations due to this possible bloom in the ocean. That needs to be considered.
That could relate to limestone formation.
Yes. I haven't brought that in because I'm not an expert. I'm not a geologist, but I can anticipate all kinds of things that this could feed into. Yes, sir.
I'd read that the mammoths, they found them with, I think their contents in their mouth preserved, and one of them, maybe Bird's Eye Foods, did, with what they know of freezing, did some research or some work on it, would have came to the conclusion that these things, the size they are and everything, would have had to be exposed to, I think it's like 150 below zero.
Yeah, that's
Any idea how this could have happened? I mean, they're there, so somehow it happened.
Okay, this is a really interesting area, and it's one that people have read about a lot. You may be familiar with the book, The Waters Above by Jody Dillow, in which he had a whole chapter on mammoths and so on. He reported in his book, he thought that the mammoths were killed during the flood itself. I initially had bought that argument, but I've changed my opinion since then for a couple of reasons. One is that the mammoths, the ones that are buried, particularly in the Siberian area, there are just hundreds and thousands of them up there. They are buried in a location which is resting on top of 1,000 feet or more of alluvial material. Now, alluvial material is material that's been washed down out of the mountains, like in glaciers and down rivers and so on. It's like river rocks and so on. The sediments and the layers, the geologic column produced by the flood, are much below that. So if they were, it would have been near the end of the flood. But I don't believe that it was during the flood. It appears that it was a later post-flood event where they were killed. The problem is, because there's hundreds and thousands of them, it would have had to have been several hundred years after the flood, because if they came on the ark, which would have been required, they would have then had to repopulate the earth to have hundreds or thousands of them killed. So the question is, why would they have gotten killed in Siberia if it was several hundred years later? Well, Mike Ord in his book back there suggests one possibility, and that is that the mammoths, for one reason or another, tended to like the climate around the Arctic Ocean. If the oceans were left relatively warm after the flood, it would have not been frozen over, and that region would have moderated the climate right around the boundary of the Arctic there. They tended to migrate there and live there, although we find them on places like Wrangel Island and in Alaska. There's all kinds of places where you find them, but they tend to be fairly close to the ocean where the climate would have been moderated. He suggests that they lived there, and then as the oceans cooled and eventually the Arctic Ocean froze over, that the climate changed suddenly and they were frozen there. Now the question is, why didn't they head south? He suggests that there was already snow and ice forming to the south of them due to the ice age, and they couldn't go south any longer. They got trapped along the boundary of the Arctic Ocean. Well, the question then comes, how could they have gotten frozen so quickly? Because there seems to be evidence that they got frozen very rapidly because of the mass and their bulkiness and the fact that they had stomach contents that were not rotten. Although there was really, it turns out, only one mammoth that seems to have that condition to that extreme nature. Many of them are more rotten than that. The only suggestion I can make is that you can quite often get very extreme weather conditions, very high winds and very cold temperatures, even today in certain locations. Like one of these storms will come off the Siberian area into the Gulf where the water is very warm, and you get very strong circulation, and you can get very strong blizzard conditions. Now, whether that's enough to freeze a mammoth quickly enough or not, I don't know. But that's the only explanation I can get given the whole scenario. If you want to read more about that, I would suggest you might buy Mike Ord's book, and he has a whole chapter in there talking about that idea a little bit. Or Jody Dillo's book, The Waters Above. We've reprinted it at ICR, and we have it in paperback available, so you can order it through us if you want. A lot of really fascinating material there. Any other questions here? Go ahead.
You were talking about the land bridges. There's also in the Mediterranean an event called the Messinian Salinity Crisis, where apparently the Mediterranean Sea went down to completely evaporate.
Right.
And I've sometimes thought there might be a correlation in that it might have occurred the same time as the other land bridges occurred. Have you read anything in that regard?
I've read a little about it, just enough to get me interested, but I haven't gone very far with it. What he's talking about is that the bottom of the Mediterranean appears to have a tremendous layer of salt deposit in it, which means that at some point, evaporates. Well, there's another term for that, I forget. It's possible that those materials are not due to evaporation, but when the crust of the earth was broken up, you had a lot of this material that was brought from beneath that formed a lot of these. There's a lot of salt layers and salt plugs all over the world. In fact, some of the salt mines are talking about storing nuclear waste and so on. It was probably not evaporated, but it was put in place by some type of a geologic process. That may have been the case in the Mediterranean, but there's the other option too, and that is that today the Rock of Gibraltar, which is the mouth of the Mediterranean, is relatively shallow, and it turns out there's a tremendous current that comes into the Mediterranean. If you try to sail from the Mediterranean out through the past Gibraltar, you have to go against about a 10 or 12 knot current flowing in at the surface level. And the reason for that is that in the Mediterranean, because it's such a dry climate, it's evaporating tremendous quantities of water vapor, and that mass has to be replaced by the water coming in from the mouth through Gibraltar. At the same time, that evaporation is producing increase in salinity in the Mediterranean, so there's a countercurrent actually going out at depth near Gibraltar into the Atlantic, which has interesting characteristics of its own. But it's possible that that area there at Gibraltar was actually a dam that was breached at some point, and before it was breached, that whole Mediterranean there went dry and evaporated, like you say. But I'm not sure there'd be enough time in a biblical time frame to get that much salt. So I suspect it's more of a geologic process, but I just don't know. There is also some interesting features there in terms of the Nile River coming in and producing some evidence on the bottom of the Mediterranean I hope to get at someday, because it tells us something about the climate of Central Africa, because the Nile drains all of Central Africa.
And there's tremendous submarine canyons.
Yes.
From the Nile and from the European rivers.
Exactly. Yeah, there's so much there to be done. It's incredible. When you start thinking catastrophically, there's just all kinds of places you can go and start doing studies. There's just not enough of us doing it. Yes?
I have two questions not related to each other. The first one is, you said 6 different models that were presented, or 8 different models that were presented on your...
Oh, I had 8 different models there.
Well, my question was, all of them were used?
To the explanation for the Ice Age, most of which are generally recognized not to be valid, except for the astronomical theory, and many people say that it has problems, but they don't have anything any better, so that's the generally accepted one at this point.
The other one, unrelated to that, because you were talking about the mammoths and freezing and things. Are you familiar, could you clarify if this really happened? Walter Lane's publication out of Minnesota, The Ark, you familiar with that?
I know Walter Lang, but I don't know.
Okay, he has a publication called that. He talked about the mammoths and the coelacanths and things that were found in various places, mainly the frozen ones. And then he talks about the salamander that was found frozen. And they took it at a room temperature and were thawing it out, getting ready to study it. And because it was able to, a little different kind of animal than a warm-blooded animal, it came back to life.
Oh, was that right?
From the same strata that these other mammals were frozen, like mammoths and things. I just wondered if you'd heard about
No,
that.
I hadn't. No.
And it crawled around and died.
Things are still going extinct. Yes, ma'am.
You asked a question when you first came in, or when you first started, about why this is called the South Bay.
Yes.
The area from Malibu on around to Palos Verdes is in a crescent shape, and in fact the Boy Scouts area was called the Crescent Bay area, and it's called the Crescent Bay area. We're at the southern end of that Crescent Bay area, and that's why we're the South Bay.
Okay, well, I'm familiar with that. I just didn't realize it was referring to that. Okay, thank you. More questions? Don't tell me I satisfied all your curiosity.
Excuse me.
Yes.
Do you have a date for as to when the flood occurred?
I use the Usher chronology as my basic time frame. I am willing to adjust that slightly, but on the difference between a short time frame and the long time frame I'm working with, a few thousand years don't make that much difference. So I just use the Usher chronology, which basically says that the flood occurred, well, let's see, the Usher chronology says from creation to the flood was 1,656 years, and we're approaching about 6,000 years from the creation now, so the difference between those two is around 4,500 years. That's why I use that. 44, 43, 44, something like that. For the kind of the modeling that I'm doing, which you'll see in some of my work back there, the equations, it doesn't make much difference when you have those big difference between a few thousand years and a few million years. Yes.
Does ICR put out a publication, or can we find one of Bishop's research, what he did, and is it all written down somewhere? Where we can
Bishop
see the
Usher?
numbers? Right.
Well, he didn't do any research. His was all biblical chronologies.
Right, but obviously he put some numbers together on paper for us.
Yeah, there is in my monograph, The Ice Cores and the Age of the Earth, if you look in the back of that in the references under Usher, you'll see a reference to his publication. How easy that is to get, I don't know, but there is a reference in there for it. Yes, sir.
You had mentioned something at the very beginning about the waters above the earth, and I'd heard somewhere somebody said it was water vapor. And I remember when I was a youngster and they first started flying, excuse me, I think jet bombers, they were talking about 40, 50,000 feet, something like 80 below zero. How could you have any water there? And see, I'd wondered if that had been once like a solid shield, similar to a glass globe up there of solid, hard frozen ice that broke up.
You're talking a whole different talk that I have.
Oh.
I have a talk. Well, it has to do with I do research on the vapor canopy, and if in fact there was water in the form of vapor surrounding the earth before the flood, the conditions would have been significantly different. It turns out water vapor is the strongest greenhouse gas there is. It's stronger than carbon dioxide or ozone, and it absorbs infrared radiation very effectively. So if you put water vapor in a shell around the earth, it's going to heat up. In fact, it heats up so dramatically that the surface temperature becomes a problem. I've been doing modeling on that now for 15 years and continue to do modeling on that. I've been able, one of my students did his thesis on this, and he was able to show that you could sustain almost any amount of water that you wanted above today's atmosphere in vapor form by the absorption of solar radiation and heating it up and therefore maintaining it as vapor. The difficulty is that it causes the surface temperature to be very hot also. And in fact, if you have one of the runs that we did using an Air Force radiation code showed that if you had 34 feet of liquid water in vapor form surrounding the Earth, it would cause the temperature of the Earth to be on the order of about 700 degrees Fahrenheit. So that's a problem. And I haven't been able to solve that. Right now, we've been able to sustain 2 feet of liquid water in vapor form and maintain the surface temperature of the Earth in a livable temperature. But I can't convince myself that 2 feet of liquid water is a major contribution to the flood of Noah. It doesn't seem to match when you're talking about all the hills and mountains being covered.
How many degrees of rain is that?
Well, that'd be 48 inches. That'd be like an inch a day for 40 days or 48 days. So it's not that much water. So I'm looking for another source of the windows of heaven being opened, and that's part of the attractiveness to me of this tectonic flood model, is that it would naturally produce a tremendous amount of evaporation, particularly during the initial stages when you had all this action going on, which would have produced a lot of rain. Now, I'm still convinced that there was a canopy surrounding the earth, because the Bible says that the Lord separated the waters which were beneath the firmament from the waters which were above the firmament. I believe He placed them there on the second day. If they were in vapor form, we got a problem. If they were in some other form, I haven't been able to sort that out either. There's other difficulties with a solid crystal sphere. There's problems with clouds because you can't see the stars as the Bible indicates you should. You can't have it there in liquid form. It would fall out or it would turn to ice. So I haven't sorted that problem out, but I'm still doing research in that area. In fact, I was given a gift of some money for this next spring to do some additional modeling. So I'm adjusting things and trying to do some more work there. So maybe I'll have some results in another 6 months or a year.
Do you have anything written on that?
Yeah, in fact, well, there's several impact articles that I've done in the Acts and Facts. It comes out each month several years ago. I'm expecting probably to do another monograph in about a year on this whole subject of modeling, which would include the vapor canopy modeling as well. There hasn't really been any extensive work published for the general public recently. My student who did his thesis presented a paper at the International Conference on Creationism in Pittsburgh 6 years ago. That's available, so if you wanted to call me or write me, I could send you some of those technical reports. Yes, sir.
Yeah, I'm talking about the water vapor. It seems to me there's two parts of the Bible that suggest that. One, where it says there was a mist in those days. The second one is that when you put the rainbow up, apparently that was the first time you saw a rainbow.
Right.
And so to me that suggests that you said somebody could see the stars. I don't know where you got that.
Yeah, that's in.
You couldn't. You couldn't see the sun the way we see it.
Yeah, you wouldn't see it in the same way. You probably wouldn't see as many stars if there was a vapor canopy up there, but you still had to be able to see them according to the description there in early chapters of Genesis. So that's part of the constraint. You can't have solid cloud cover or else you can't see them. So there are some major constraints there's about 7 conditions that you're constrained by there in Genesis. And I agree with you. That's the reason I hold to the idea that there was some kind of a canopy before the flood that made the climate different. I think it may have been associated with the longevity of the patriarchs. The fact that the rainbow was not evident until the rain started later. Now you have to understand that the Bible does not say it did not rain until the flood. It just says that it did not rain there the initial days. I'm interpreting, and I think many that are in this area as well would interpret that as saying it did not rain over the entire earth from the time of creation until the flood. That's why I'm doing the modeling I'm doing. But the Bible nowhere says it did not rain from creation until the flood. It just said it didn't rain there in the first few days in the Garden of Eden. That's specifically what it's saying. So we're still doing a little bit of interpretation there. Yes, sir.
What sort of assumptions do you use in your model regarding the temperature of the core of the Earth and how far up the hot temperature goes towards the surface?
Okay, Dr. John Baumgartner is a geophysicist at Los Alamos National Labs, and he is the one that's doing the modeling on that. He is using the data that he has for what the temperature distribution is today in the mantle. I don't know that off the top of my head, but it's probably approaching a couple thousand degrees, I think, for the temperature. It depends on how far down you are and so on. And this material is plastic. It's solid material, but it's plastic. And when this chunk of material goes down through there, it gets even hotter because of the tremendous friction and so on associated with it. For me to tell you any more than that, I have to refer you to John. It is very hot, though. We're talking thousands of degrees. Yes, ma'am.
I'm interested in other evidences from some of the other cultures, ancient cultures, where there is evidence of like legends of the flood story. I wondered if you had any books that would touch on that.
That book by Jody Dillow, Waters Above, he has a whole chapter of about 60 pages that talks about that. That's one of the major pieces of evidence he brings in to describe the fact that this is not just an isolated thing that shows up in the Bible. It shows up in all the cultures around the world. In fact, some of the references are very specific in terms of what the boat looked like, how many people were on the ark, all the animals, and all that sort of thing. And so he has a lot of references to that. If you want to call me or write, I'll be glad to, or you can just call ICR and ask for that particular book. That's an excellent source. That'd be a great starting place because he has all the references also so that you can go from there back to the original sources.
In regard to the previous point about whether there was sufficient water vapor to produce the rain to cover the oceans, I think the more important factor, and you mentioned this briefly, is the lifting of the ocean bottom due to the magma covering the ocean bottom. It just lifted the ocean bottom and just caused the water to flow over onto the continents. And so it wasn't really dependent upon just the source from the atmosphere.
That's right. You know, one thing you need to understand is that probably all the water that was here before the flood is still here. Whatever was in a canopy, whatever was in the oceans is still here. It's likely that the distribution of the surface of the earth is considerably different today than it was before the flood. That if you took all of the water on the surface of the earth today and put it in a shell around the earth, it would be about 8,000 feet thick. So you could have hills and mountains on the earth before the flood up to 8,000 feet, and they'd still be covered even then. You could probably have them even higher than that. But after the flood, you had tremendous changes in mountain building and all kinds of things. The mountains we have today and the big deep canyons in the oceans today were formed probably in the processes associated with the flood. But there was probably not a 25,000-foot mountain like Mount Everest before the flood, nor was there a 35,000-foot trench in the ocean as there is today. That's all been a process of the flood itself. I would just add that Dr. Austin, who is really an outstanding creationist geologist at ICR, is really doing some really neat work out here in the desert near Las Vegas. He and Dr. Wise, Kurt Wise from Dayton College, have been going out and mapping what they call megaclasts. Megaclasts, it's these big rocks that are on the order of a mile or two in size that are buried in the desert in the Kingston Range out near Pahrump, Nevada, west of Las Vegas. And the significance to these are that it's evidence that there was massive amounts of water moving large boulders and debris across the desert in particular directions. Now, the model that we are using currently is that at the initial stages of the flood, the waters were from the ocean onto the continent, bringing sediments onto the continents, And near the end of the flood, the water was coming off the continents back into the ocean, bringing the sediments and eroding the top surfaces back into the ocean. Associated with that was mountain building and the movement of these gigantic chunks of rock. And they're beginning to map these out in the desert now and beginning to see a movement of these big chunks plus motions of fluid flow in the desert. So that's what's exciting about going to our Grand Canyon trip. We take you out in the field and show you firsthand these kind of evidences and interpret them from a catastrophic flood model. I don't know, maybe we ought to come to a close here pretty quickly. Let me just finish with this comment. There are two pieces of evidence that strike me very strongly about evidences for the flood in the Grand Canyon. One is when you look at the strata, such as the Coconino sandstone, which is 300 to 400 feet thick. If you've been to the Grand Canyon, look over the edge, you'll notice that there's layers in the Grand Canyon. And there's one layer that's lighter than the rest. You can see it all the way around the edge of the canyon. It's kind of a vanilla color, and it's about the third or fourth layer down from the top of the rim, all the way around the canyon. That's a Coconino sandstone. It extends all the way from Southern California over into New Mexico and Texas, from the Mexico border up into Colorado and Utah, and it's several hundred feet thick. There's evidence that that layer was laid down by moving water. A number of geological evidences, which are too technical to get into in a brief period of time, but it appears it was laid down by moving water over large distances, covering 4 or 5 states. If it took moving water to lay that down over an area of 4 or 5 states, what would be the source of the energy to produce a wave that would move that much sediment over such a large area? It would have to be global in extent. That points back to the flood of Noah. Another piece of evidence that we take people to in the bottom of the Grand Canyon, the bottommost sedimentary layer in the Grand Canyon is called the Tapete Sandstone. And it's about 60 or 80 feet thick. And at the very bottom of that layer of sandstone is these giant rocks that are this size, down at the very, between that and the crystalline rock beneath. There's the Vishnu schist and Zoroaster granite, a lot of terminology here. But it's a rock that's not sedimentary, it's metamorphic and igneous, and it's overlaid with a sedimentary rock, which we believe was produced by the flood. But the boundary between those two is very sharp. You can take a pocket knife and stick in between the boundary of those two. Just above that boundary, in that sandstone, that Tapete sandstone, are these big chunks of rock that are of the material down beneath. So it appears that a river of water moved across that, ripped up that lower rock, and when the sediments were laid down, it had some of these chunks of rock left over, and they got set up in the sediment and were sitting there in the sedimentary rock when it was solidified. Now, some of those are the size of a dump truck. We found one that's the size of a house. Now the question is, what type of water flow would be able to move rocks that big and rip them out of the rock beneath and lay them and leave them there in that sedimentary rock? I think the only answer to that would be a flood like Genesis flood. So those are the kind of things we'd love to take people to and show you. If you can backpack and get down there, or can afford a raft trip, we'd love to take you to those kind of things. I think I better quit. I think people are starting to go to sleep on me here.
Okay. Thank you very much.